Good morning, students. Today we are going to learn about concrete in aggressive environment, where we are going to find out what are the reactions going to take place in concrete when it is interacted with other materials or other salts or any other material in the general natural resources or in the environmental or atmosphere. So concrete in aggressive environment, we are going to see how it is going to change the concrete validation, concrete design period, or concrete structure, concrete texture, and the durability of the concrete. So if you see the syllabus of concrete in aggressive environment, alkali aggregate reaction, so how alkalines are going to react with the aggregate and how it is affects the durability of concrete. Next one, sulfate attack, chloride attack, acid attack, effect on seawater, special coating of waterproofing, sulfate, chloride and acid attack, concrete for hot liquids. So when it is comes under the exposure of hot liquids, what are the reactions that going to takes place and how it is going to change the properties of concrete, we are going to learn in this. So CO3, we are going to learn about aggressive environment and special concrete. So the introduction, the general environment to which concrete will be exposed during its life is classified for 5 levels of severity, namely mild, moderate, severe, very severe and extensive as described in table. The destruction action of aggressive water on concrete is progressive. The rate of deterioration decreases as the concrete is made stronger and more impermeable and increase as the salt content of water increases. Whereas structures are only partially increased or in contact with aggressive soils or waters on one side only, evaporation may cause serious concentration of salts with a subsequent deterioration even where the original salt content of the soil or water is high. So if you see the environmental exposure conditions, so what is mild and what are the generally we are going to give certain ratings of the effect. So environmental exposure conditions and how it is going to take it as a mild one, moderate one, severe, very severe and extreme. So if you see concrete surface protected against weather or aggressive conditions, except those situations in coastal areas, will be considered as a mild one. So if you see the moderate, concrete surface shelters and severe rain and freezing while wet weather conditions exposed are condensation and rain. So it will be certain moderate conditions where the concrete can be exposed. So severe means concrete surface exposed to severe rain, alternate wetting and drying, occasional freezing and condensation, concrete completely immersed in seawater, concrete exposed to coastal environment. So it's the exposure will have certain longer period where you can see that it's severe. If it is very severe, it will be considered as seawater spray, corrosive formation or severe freezing conditions, wet and dry conditions and buried under aggressive subsoil groundwater. So it will give you a severe conditions of concrete. So extreme means surface of members in tidal zone, members in direct concrete with liquid, solid, aggressive chemicals. So if you see the introduction, a site where alkali concentration are high or may become very high, the groundwater should lowered by drainage so that it will not come in direct contact with the concrete. We may discuss following aggressive environments for a concrete. One is alkali aggregate reaction, sulfate attack, chloride attack, acid attack, effects of seawater, effects of de-icing salts, efflorescence, resistance of concrete to fire. So if you see the alkali aggregate reaction, so namely aggregate used in concrete are considered as inert materials but some of the aggregates contains reactive type of silica which reacts with alkaline present in cement and sodium oxide, potassium oxide. As a result, the alkali silicate gels or unlimited swelling type of form. This reaction is called alkali aggressive aggregate reaction. The type of rocks which contains reactive constituents include traps, rhodiants and certain types of salt stones. The reactive constituents may be in the form of opal, skarts, volcanic glass, zeolite and many other. So if you see the alkaline silica formed by the alkali aggregate reaction is confirmed by the surrounding cement paste, and internal pressure is developing, leading to expansion, cracking and disruption of cement paste. So this expansion appears to be hydraulic pressure generated through osmosis, but it can be used for swelling pressure and still solid products silica reactions. So see alkali aggregate reactions. Factors promoting the alkylate aggregate reactions are reactive type of aggregate, high alkali content in cement, optimum temperature, availability of moisture, fineness of cement particles. So alkali aggregate reaction, as mentioned earlier, certain type of rocks like traps, silica, limestone, certain or stones contain reactive constituents. The aggregate derived from such rocks are reactive and may promote the alkali aggregate reaction. The high alkali contents in cement is also an important factor contributing to the alkali aggregate reaction. To prevent the deterioration of concrete due to alkali aggregate reaction, alkali content in cement should not exceed 0.6%. You need to make it a mark like should not exceed 0.6%. So when it comes to the ideal temperature, alkaline reactions range to 10 degrees to 38 degrees. If the temperature is below 10 degrees or more than 38, it may not provide an ideal situation for the alkali aggregate reaction. So measures to control alkali aggregate reactions: selection and non-reactive type of aggregate by restrictive alkali content of cement below 0.6%, controlling temperature, controlling moisture content, corrective admixtures such as pozzolanas, and avoid space in concrete which not using very fine ground cement. So this is the alkaline silica reaction. If you see, it is the cracks that can be formed when it is interacted with certain alkaline nature. So sulfate attack, this sulfate attacks we are going to learn in the next session, where we are going to go in depth of sulfate attacks and their different chloride attacks and everything we are going to study in the next session. Thank you.